Hello everyone, and in this video today, I will continue our VEX part. Then I will talk about wrangle. Why do we call this attribute wrangle, where we write our VEX code? Then I will review the things that we learned in the last video, and then I will continue with today's video, and I will talk about how you can create parameters in the node UI and how you can control those values from the UI itself. Then I will talk about how you can create the ramp from the VEX. Then I will also talk about how you can fit range from the VEX. All these things we have covered in the VOP, and we created these by VOP nodes. And I told you that VOPs are a way we are writing VEX but through nodes. But in this video, I will talk about how you can do it by VEX. Okay, so let's start this video. And I have already created some notes, but we will review these notes when we continue forward with this video. And first, let's create something. What do I want to create here? Helix. I want to create a helix this time. And you see we have a helix, right? Okay. So what we were doing in the last video, we were creating first, why do we call this wrangle? Because wrangle means to manipulate, modify, control, and deform, right? So in English, wrangle means to control, manipulate, modify, change. And Houdini, we are using the same logic, but we are saying here we are wrangling our geometry, we are changing, modifying, controlling our geometry through code. That's why we call this attribute wrangle. We write our code here and we control, manipulate, and modify our geometry through code. First, simple, let's create a float variable. Float variable name, let's say variable, and give this a value 1.3 and this by this a semicolon. We talked about this in the last video, and this float variable lives here. It is not an attribute, it's just a variable, it's just a value, and this value is float value, right? Okay, let's create an integer value, int, and I want to say this I variable, and its value would be, let's say, 2. And this is also our variable. This lives here on this float. We have vector. And let's say, what do you want to call this vector? I want to call this a b, you can say same variable, and its value would be in these curly braces, and we have 1, 2, and 3, and this, and we have this vector variable value. Now we have these, we have created these. We can create string, right? Let's say string, and let's create string attribute. Can we create it? Let's see. Attribute, string attribute. And what do you want this attribute to be called? I want to call this as string, and equals to, string is a text, so we need to put this in quotation marks, and I want to say this ss string, just my interest. You see we have this string attribute ss string, and I want to share one important thing here. I guess I shared in the last video also, that this string is the attribute name. This string is the attribute name. This is attribute name, not string. This is a text, which is a string. So we have created a string attribute, and that's why we are seeing a text where we see values, right? Okay. Now, what if I want to create a string variable, a constant? Let's type string, and I want to call this ss, or you can say s, and variable s means string, and give this a string. How you can say string, what is the text? String, you can say s text. Why not? This is just a variable and it lives here, here at this what to say, node UI. This is UI. These are options we can, like, this is the UI, user interface, and here we can like modify, change our values. We can put change values, and we have created our constants. Let's create vectors. Vector. Now let's create vector attributes. Vector, and let's say CD. CD is for color diffuse, and we are referencing the CD attribute, and we are creating, and we will assign the CD some values. What do we want this CD to have? 1, 2, and 1. Okay, now we would see some CD values, and when I wait a second, put this 0 and put this, when I give this 1, 0, 0, now you see our helix is turned red. Okay, we have created this, and in the last video I also talked about set, right? Because we have different variables, but I cannot say, what if I want to put this CD, our value, our vector component, our component value is this variable. We cannot do this. When I put CD here and I say I variable and 0 and 0 and curly braces and finish this code, it would give us an error, because I told you in the last video that these curly braces, inside these curly braces we can have only a fixed constant value. We cannot have a variable. We need a fixed value, a constant value, a fixed value, a value that cannot be changed from anywhere. We can change it by here itself. That's why we can have the numbers not, but we have this set. What we can do, we can say CD, and I told you in the last video that when we created our first CD, this CD is now overwriting this, and this CD are now overwriting these both. When I said how I can put this, we have different rule. We have this set. Now you can say I want to set this, but I variable and 0 and 1 and finish this. Now you see, now we have a variable inside a vector attribute. So when I change its value, you see we are changing the color. Let's say this value is 10. You would see something like put the 0, we would see red, right? Because this I variable value, we are getting it from here. If this changes, this also changes, but we cannot put this variable here, right? Okay, now this is from the last video, and now what if you can just delete this if you want, but no, let's continue. What if I want to create. I told you that I will create a parameter in the UI. We can like manipulate from the parameters. So to create a parameter, we have this. To create it, what we need first, float, right? Okay, what should I call this? Let's say f value, and now we have channel. We have channel, and I will tell you what I'm doing. We have ch, and this data type is float. We will say f and our brackets. Now what we want to call this parameter, and I want to call this float and value and this. Now when you run this, you would see our parameter f value. You would see our parameter f value you just created. And I want to show you, I want to tell you something here. These CHF, this means channel f. Now what is channel? Channel is the value that lives here. This is our parameter, this is our parameter, this is group type, our parameter. So first, what is a parameter? Parameter is a user controlled value. Everything you see in this UI is a parameter. This group type is a parameter, this group is a parameter, this f value parameter is a parameter, this bindings, these are parameters, and we have this CHF. CH means channel. CH channel. Channel, these values, these parameter values are channel. And we say Houdini's, it's like Houdini's internal language. They say it, like it says it channel, these values, it say it channel, and this channel like lives here. But when I'm saying the float value, the float f value, we have created this channel f. That means channel is like parameter. Don't get confused, it's just how Houdini like thinks internally. It calls these values channels and these parameters. And what we are doing here, we are creating a float parameter on this UI, on this node UI, and this float has name f value equals to channel f. Channel f, that means we are creating a float value parameter, and this channel f is reading its value. If you create more of these, then you will understand what I'm saying. Let's create a vector, but in like channel, and in this parameter UI, we would say vector. You can create an attribute, or you can, let's create an attribute vector. What should be this vector attribute name? V value. You can say V attribute. Okay, it's just a name. You can have any name. And I want to say this is a vector, so we want channel V, and we want this name to let's say vector value and something like this. So when you run the code, you see we have this V value parameter, and inside these values are now channels. So this channel is reading this V value parameter values and assigning it to this V attribute. You see we have V attribute, and these V attribute have three components. It's X, Y, and Z. Here we have 0, 1, and 2, and that's how we can create parameters by VEX. We have covered how you can create the float variables, integer variables, vector variables, strings, and vector. How you can set the variables inside the vector, which you cannot do here in these curly braces, but you can do by this set. Uh, how do I say set code? What's the word code? Set code. You can say set. It's a rule. This is a like you can say code. I hope you understand this, but my articulation I'm trying to improve, and I'm trying to improve how I like share my imagination, my thinking. But I hope you understand this what I'm saying. And we have created this vector attribute, but in this parameter UI in channels, right? We have R, X, Y, and Z. Here it is 0, 1, and 2. Okay. Now you understand what is channel, and I have created notes you can read here. Parameters is a user-controlled value that affects a node or code. Channels the stored animated value channel. I would say forget about this. Just see the values here inside this parameter UI. Inside this parameter UI are channels. Houdini stored these values as channels, and it assigned those values to, like for example here it is assigning this channel V value to this V attribute, right? You don't need to go like very let's say in deep to understand, because we are understanding here VEX, but I've just told you what our channels are and why do we Houdini call it a channel. So you can say you can create a parameter in the UI name scale. Let's create an example. Let's create an example, and I have created C. I have this channel vector CHV, channel float, CHF, channel, and CHF is a function, channel float. Okay, read a float parameter from the node UI. Channel float, this is our float parameter, and this channel float is reading those values, and those values are in channel. It is storing, Houdini is storing those values as channels, and now and it is assigning these values, the float value, the channel value. We can exchange, we can control, we can manipulate this value from the parameter float value in this UI, and it is assigning the value to the f value, to our float variable name, to the float variable. Okay, you can see vector read a vector parameter from the UI. Here it is reading the vector parameter, and it is doing the same as for everything we have. And we have chi, which is channel integer. I can create something with this. Let's create integer attribute. Let's say I, where is I? Okay, attribute, and you can say chi. I want to call this I value. Run this, you have this I. This is our integer. Let's create a float also. F, I say F attribute, and you can say CHF, and I want to say this float value, and finish this, run this code. We have a float, and you see it is in points, but these are the whole numbers. So I hope you understand how you can create parameters here. And what are these? CHF, CHV, CHI, right? Now the main thing. Okay, we have our helix, right? Let's create an attribute VOP node, and let's give these points some p scale values, right? By the VOP. We have been doing this a lot. I hope you can do it by your own. I guess if you can, then you are like learning really fast, because it's very simple, it's basic, and these concepts are like important but a bit difficult to understand at very first. But I make sure that I tell you what I know, and try to explain it the way you can understand. If you have like any doubts, you can leave in the comments. If you are watching this and you have any doubts, you can leave in the comments. Let's create our bind export. Bind export is to output the value, right? We know this, right? Okay. Let's create our constant. I'm going to create this p scale and connect this into this. Now we have this p scale and its value is 1. When you go here, you see we have our p scale value which is set to 1. And what if I copy a sphere? Copy a sphere, and here, not what I'm doing. Copy 2 points. Copy this, this to this. Now we have our sphere. You can decrease the size of the sphere by decreasing its radius. Okay, that was my notification, my phone notification, ignore that. Okay, we have something like this. So each point has a p scale value of 1, and we are copying this sphere, so it is also getting the p scale value from these points. I have created the p scale values from this VOP, and how you can do the same by the VEX. How you can do it? Let's do this. Okay. P scale value is a float. Attribute p scale, and you need to write the right spelling so it can work, because syntax rules. And let's give this 1.2 or say 0.5 and this. And when I connect this to this, you would see something like this, and we have a red color because of which variable? Because of this color attribute, and I variable value is coming from this, which is 10 is really huge. That's why we are saying these bright red balls. When I give this 1, you will see something a less luminant balls, and these points have p scale 0.05. But let's connect this to this, and inside this, let's understand parametric coordinates. And when we were working with relative to the bounding box, I haven't talked about this then, but now I want to talk about it first, then we will move forward. And parametric coordinates are really simple if you understood the relative to bounding box, and it is really simple, but it is important that we should understand it first and move into the next part. And I will explain it really simply so you can understand it. I have created the notes also, as always. And first we will create our scene or some short project example, then we will jump to the notes. First, I need to explain this, what are parametric coordinates. But first, let's create our plane. I'm in the geo container, inside this geo container, and I will create a grid. And you can say like 2 and 2. And these data types are type of integer, because these are not in fraction, they are not in points, they are exact values, the whole numbers. From it can be 0 to 1 up to like unlimited. And I have this grid. And now let's create our attribute VOP. We have been working this in the attribute VOP, and I think now you understand how attribute VOP works. These are vector VEX operators, and we are writing codes but through nodes. And in the next part, when I would explain VEX, I will also tell you how you can create the same by the VEX. So here I am inside this attribute VOP and toggle the display on, and inside this, let's create our relative to bounding box. And let's give this position P. And okay, why position P? Because we need to read the point position first, so it can give these position a value, these points position a value. Okay, what I'm talking about here, first let give this vector, and the value that is coming out from this P going into this input of the relative to bounding box are P. These point positions values are in vector. You would see here we have these points, right, and their values, their positions are in vector. So they are located, this point is located -5 in the x, 0 in the y, and -5 in the z. So we know their exact location. We have these 4 points, right? Okay, now we are reading this, and what this relative to bounding box is doing, it is assigning these points values, these points values according to their position inside the bounding box of this geometry. What is bounding box? I told you about that. It is the uh, it is the box where the geometry can fit like completely. It is the minimum. It is the minimum rectangular box. Inside that geometry we can fit the geometry, and this bounding box is like invisible. We cannot see it, but we have this geometry inside that bounding box. I have cleared the bounding box in when we were working with the relative to bounding box node for the first time. So now we have this, and we know that the value that is coming out from this output of this relative to bounding box VOP node is when we connect it into the CD. Now we see some colors because the value that is coming out from this is now going into the CD, and these values will go here. We see colors because we are getting all the values for all these channels. So this point is getting these values, this point is these values. So what is relative to bounding box is doing, I will share in a bit. Let's convert these vectors to uh, these vectors to vector to float. And now what we are doing here, we have converted this vector. We have like what's the word? We have like separated the vector into uh, three vector components. It's x, y, and z. Float value 1, float value 2, float value 3. Now we have the 3D vector, and we are converting this vector into like their each component float values. So we are getting is float values for each vector x, y, z components, right? So the value coming out from this is going into the CD. And now, real important thing. What is this relative to bounding box doing? This relative to bounding box is doing, it is assigning, I have already told you about this, it is assigning values from 0 to 1 from the we can say from the one end of the geometry inside this bounding box to the other end. So here we are seeing, and it is doing this for like every axis x, y, and z. So when you see here, we see our value from this is like you see 0 1 0 1 0 1, and I will show you how. So here when you see right there, look at here, and wait, okay, now you are seeing the white color is in the x positive, and you are saying the black color is in the x negative, right? I have talked about this, that these 2 points are getting a value 0, these 2 points are getting a value 1, and these points are like far from in the far of the bounding box. This far, every point here will get a value 0, and every point at this end of the bounding box, the geometry inside this bounding box will get a value 1. Now when I to make it clear, when I increase the rows and let's say 3. Okay, now inside this you see I will give you exact example, exact point value. So you see we have this point 0, and when you go in the geometry spreadsheet, and I'm sure that you will see its CD value 0, point 0 CD value 0, because these points are at the this far end of this geometry, and these points are this far end. So it's these values, these points are getting a value 1, and these points are getting a value 0. So all these points are getting a value between 0 to 1. The value is in the range between 0 to 1, and all these points that are at the middle of this geometry are getting half of the value from this 0 to 1. Every point inside this will get a value from 0 to 1. This is what relative to bounding box is doing. Right? Okay. Now what are parametric coordinates? Now you know that these points have value 0, these points have value 1, and these are their position values also. You see we have position, and now we have we have the value that is coming out from this is going into the CD. So we have these position values, and these position values we are now converting into the CD values. So these points have the CD value 0, these points have the CD value 1. Now you understand this. Now what is parametric coordinates? Okay, very simple. We know that where this point exists on this geometry, right? We know where this point exists on this geometry. We also know where these points exist in this world, in this 3D world. We have their positions, right? Here, what parametric coordinates are: the values of their values of these point position according to their geometry, according to their local position. What do I mean by that? Understand, listen to me really carefully. We know where these points exist in this world, in this 3D world, right? But what if I want to have their location according to their local, locally on this particular geometry? So what do we do? What Houdini or any other 3D software do? It assigns these points values from 0 to 1, 0 to 1, 0 this far, 1 this far, right? And the values between between 0 and 1 are parametric coordinates. Their positions on their local space, not in the world space, but locally, where they exist locally. And we have two things, u and v. We can have another if it has depth. Volumes have another. We have two, we say it u and v. U is left to right. This geometry we can say u left to right, and v from bottom to up, bottom to top. Now I have created the notes and we will read it. We have the note here. Parametric coordinates are values, usually 0 to 1, that describes a point's position along a shape, not in the world space. We know where these points located and how by assigning these points some values from 0 to 1. So these points are now located at the very bottom, so their value would be in between 0 to 1, half. The value would be 0.5. So they are located. So this point is located at 0.5 of this 0 to 1 of this geometry. You understand it? I guess you do. And we can have, like, I would give you another example so you can understand it better. Like a percentage of of shape shape shape. Okay. A coordinate in the space on local a coordinate in the space on local space. I don't know why I write that. It doesn't make sense. Here, okay. U is like, if you left to right, right? U0, these points have value 0 and these points have value 1. So start, end, and surface we have U left to right, V bottom to top. Where am I? Or you can say, where am I on that shape? Points are saying where I am on that shape. And you can say, instead of where am I on the world, where am I on in the world? You can say, okay, now I want to give you another example so you can understand it like better. I don't want you to forget this. Okay, let's create a helix and give this a resample. And like, no need to understand these. What I want you to understand is parametric coordinates. And here a really cool interesting thing. You see, here we have curve U attribute. I have already talked about U, which is from left to bottom. These are like terminologies like X, Y, and Z. So you have U and V, and you have another if you have volumes. But remember these U and V. But here, toggle this on. We have now an attribute curve U. Curve because this is a curve. And U left to right. But here, this is just a curve. It doesn't have polygons. It doesn't have like depth or anything. It's just a curve with only vertices, with only these points, and we can say edges. But when we give this, like, this is just a curve and curve don't have edges. When I give this sweep, now we are giving these edges, but no need to worry about this now. Let's delete this. We have this curve, and this curve has one starting point and one end point, right? So how do we assign this curve a value from 0 to 1? How do we tell, like, where is the point on that curve, not in the 3D space? So this curve U attribute gives each point a value. These far points will get value 0 and 1. Everything inside, every point inside this curve, on this curve, will get a value from 0 to 1. These far end points will get 1 and 0, and every other point between these will get a value between these. I can show you. You open geometry spreadsheet. We have curve U attribute, and you would see this point will get a value 0 and this point will get a value 1. And I can say this is also a type of parametric coordinates. We know where each point is located at their local space, not at the world space. You can screenshot this and coordinate in the space in their, you can say, their own local space, not XYZ. You can say here, so these points will get 0, this point will get 1, and I can what I can do to make you understand it better, we can like toggle this on, curve viewpoint attribute, and you see this point is getting 1 and this point is getting 0, sorry, and this point is getting 1. Every point between these will get a value, and it would be between 1 and 0. Now when you know parametric coordinates, we can assign this helix a resample node, and by this resample, curve U attributes, and toggle this off, and we have this curve view, and when I toggle this on, we have nothing because oops, wait, we have nothing because we have to assign the p-scale value to the curve view, so we can have the exact same values as the p-scale values. And here first we need to read the curve view, and we have this point. We have talked about these two when we were working with our VOPs, and we used these a lot at that time. So I hope you know what are these. I don't want to waste our time explaining these two. So let's create our let's read our curve view, and now we are reading the curve view and put this into this input. So now the curve view values are like the p-scale values. So when you see geometry, curve view, and now we have curve view as the same p-scale values, and now these points have p-scale values at the same curve view values, you will see something like this, right? Okay, how you can do by the VEX itself. What you need to do if you want to assign the curve view attribute values directly to the p-scale values, we need to have our p scale equals to, and I want to say it f, which is float. Curve view attributes are in float. Curve u, and this, and when you toggle this on, you will see something like this, right? Now how you can give this, how you can manipulate these p-scale values through a ramp. What we can do, we can f p-scale equals to ch ramp, and ch ramp is same as channel ramp. We are creating a parameter here, and in this you need to tell what should be this parameter name, and I would say scale. And like p scale, when we are creating a ramp, when you were working with VOP, when we created a ramp parameter and we connected this, now you know that this curve view values are from 0 to 1, right? And these 0 to 1 values are now are now going into this ramp. Ramp also works with 0 to 1, so it takes the 0 and 1 value and creates a graph, and you can change or manipulate those values through that graph. And now it is giving us 3 values, and we also talked about this when we were working with ramp, spline ramp, float input and float output. And when you say here, you see a ramp parameter, and when you increase the value, you would see something like this, right? And you can manipulate this p-scale values. And what it is doing here, it is taking the curve view values and we can manipulate it by the ramp, and those values that are coming from this ramp is going into the p-scale input. That means the values coming from the curve view is going into the p ramp. Ramp is changing or manipulating those values according to this parameter. You can change it. Now these values are going into this p-scale. Okay, how we can do the same? So we are creating a ramp. Now we said that our p-scale values would be like this, would be manipulated by this chramp. So chramp will read the values from this parameter. So we don't have the parameter yet because we haven't created it, and this chramp would assign this value to the p-scale. Now we said that chramp will read the values from this parameter. So this parameter we haven't created it. We have said it would be by name scale, and scale is in quotation mark because it is a string. And like we did here, ramp needs an input because it needs values from 0 to 1, so it can manipulate and we can change those values. It can create a graph of those values. But when we are saying here, we are just saying that put like create a scale parameter, and then what is the input. So we need to give this an input. What we have our curve u attribute, because the values that are coming from the curve u would go into the ramp and it would then manipulate or convert those values, right? So let's give this input. We say f at the rate curve u, right? And when I end this, you would see something like, when I run the code, you would see something like this. And when I put it, oops, when I put it here, you see something like this. So we have created our scale by this. So this curve view is the input. This is the name of our ramp parameter, and this is the ch ramp, which is the value. This ch ramp, channel ramp, is the values reading from this parameters and assigning it to the p scale value. So when I manipulate this, wait, okay, so why it was not working? Because we have the wrong spelling of our p scale name. So give this p scale same p scale and it would work now. You would see it is working now. So what we did as the same this, we like connected we created our ramp parameter, and this ch ramp, the value inside this is reading this and it is assigning it to the p scale values. So when we open our geometry spreadsheet, we have a lot, but just see p scale, and when you see this, the values are changing. Okay, now ch ramp. Now how we can put, how we can fit, how we can change these values into a different range, right? Like we did with the fit range. So the values that are coming from the ramp are from 0 to 1. Why? Because here you see these are the value. Ramp works from 0 to 1. But what if I want to have my p scale values from 0 to 2? That means we need to change the range. So right now the value is coming from 0 to 1, and we want those values to convert to in the another range, to go in the another range. Now we want the same values but in the range from 1 to 2. 1 to 2. So we talked about fit range in the VOP part, and fit range does the same. We know that the values that are coming from these ramp node are from 0 to 1, and we want our output to be in 1 to 2. So 0.2 from 0 to 1 would be equal to 1.2 from 1 to 2 percentage, right? We would do the same through this VEX. Now I want to change the range of these values that are coming from this ramp into a range between 1 to 2. How can I do that? As I did with this fit range VOP node, I want to do it by the VEX. How we can do this? First, I will give this value a variable. I will create a variable but with this value. So the ramp value would be a variable. It would not directly assign to the p scale. It would first be a variable. So we can put this variable in our fit range code. I will explain how. First, let's create this a float, and float. What should we name this float? Let's say value, or you can say f fit value because it's a fit range value. And we do the same ch channel ramp and scale our scale, which is our parameter name, and attribute. Which attribute we are reading? Curve u. Okay, now we have this float variable fit value, which is equal to the values that are coming from the ramp. If we change here, this fit value will also change because now fit value is the values that are coming from this ramp. Okay. Delete this. Now we have our variable. Now let's give this fit range code. F p scale, the same mistake, p scale equals to fit. Now we have different types of fit. Fit, you can put like any value, minimum to maximum. What is the input? You need to write the input here. But we have this fit, that means the value that are coming is from 0 to 1. We have 1 to 0 as 1 to 1. So we know that the values that are coming from this curve u are from 0 to 1. So we can choose fit 0 1 because we need the input, right? Okay, select this, we know. Now, okay, we need to put the attribute here, and we have this fit value, attribute float. Okay, now we know that the p scale is equals to fit range, so it is now converting the range into what we want. But this fit 0 1 knows that the input is from 0 to 1 because curve u, this ramp is giving us a value from 0 to 1. Yes. Okay, now we know that the values are from fit value. This is this variable which is coming from the ramp. We know the input value, but now we need to assign, we need to tell this what is the output values. We can simply type our minimum and maximum values. So we can say 1 and 2, and you can just close the bracket and our semicolon, and now you have our fit value, which is, it was capital, give this. Okay, now we have something like this. So now the value which is coming from here, this is 1, this is 0, and when you slide this 0 value, you see it is not like it is not disappearing our spheres because the p scale value from this ramp is 0. Yes, but we converted that value into the different range. What I mean by that here, the value that was coming from 0 to 1, and let's say example I have 0.02, or the value let's say 0.02. Okay, this mean 20%, right? I've explained this a lot, but okay, I can explain it again. This video is getting longer, but it's okay. Now the range, we are converting it into 1 to 2, right? And the value and the 20% would be 1.2, right? And what is the, like, 0 means nothing here, 0 means 1. That's why we are seeing when the ramp value that is coming out from this fit value is 0, we are now converting that 0 into the range from 1 to 2. I want to tell you something here. You can like create this as a parameter so we can control its value from here. That's why Houdini is so flexible. You can create the parameters as you created here, and you can like put it here, so you can change its minimum and maximum value through these parameters, right? So let's say what value do you want? Let's say integer value, chi integer, and what minimum I want to say this minimum, and close this. We need to close this, right? And I want to say this chi again, and I want to say this like max, and you have to close this also. And when you see this, when you run the code, you have your minimum and maximum values. And what's the good thing? You can like change the minimum and maximum values you are doing here. So this video is really long, but I hope you understand this VEX part, and in the next video I will see you again, and until then, take care.